So those are just a few of the kind of applications outside of the study where immunoassay could be used. The hyperthyroidism and kind of assessing for cardiovascular risk. But we're going to get into how immunoassay was actually used in this study. So this study used a Microgenics ETG immunoassay reagent. And so what this is kind of the reagent that you put into the well plate. So if you remember back to one of the first slides when we were talking about immunoassay, you've got your wells, and then in your well you put the antibodies. So let's say they're kind of like this. And so those are going to be able to detect the ETG if you put it in there. So let's say I fill this up with my sample, my vitreous humor sample, and it's got ethanol in it. And the ethanol is going to bind specifically to this antibody, and that is kind of how it's going to hook. And then you're going to add another antibody in, and that's going to bind specifically to that ETG, kind of like that. And then you're going to add a kind of colorogenic enzyme, and that's going to change color of the solution once it detects. So if we add that in there, so once, let's say, it detects this antibody, this whole system, then it's going to change the color of the well. And so that's kind of the way it's going to work. And so they use these reagents that were specific to this ETG and its ability to kind of grab onto that. Once they had filled the well plates, they used this large machine. They call it an Abbott Architect C8000 clinical chemistry analyzer. And so this is a big machine, costs a lot of money, and it's going to analyze all the samples for the presence of the ETG. Some of the samples they did just plain without pretreatment, or sometimes they did a 1-to-1 dilution with 0.9% NaCl. And so the ones that they did this dilution with were ones that had kind of a viscous gel. So remember, the vitreous humor is kind of the gel of the eye. The gel of the eye is going to be a little bit kind of thick, kind of a thick liquid. And so it's going to be a little bit viscous. So if they dilute it with this NaCl, it's going to be a little bit less viscous and a little bit more able to work and be recognized there. They also use the calibration range for this machine of 0.1 to 2.0 milligrams per liter. And so they have this range. And so samples that are within that range are just fine, but samples that are above that, they needed to dilute a little bit. So they weren't quite so concentrated. And so to do that, they just use more of that 0.9% NaCl because it's not going to bind with anything, and it's going to help kind of dilute it a little bit. So then they created a calibration curve similar to what we have done in class. They call it an ROC curve, and so it's going to calibrate the specificity and the sensitivity of this of these tests and kind of make a good curve. And they found a pretty good linearity there, so a pretty good linear line. They counted ETG as being kind of present in the sample if the concentration that they measured exceeded 0.3 milligrams per liter. So pretty low seeming amount, but just kind of speaks to how good this test is at recognizing ETG in their eyes. They also analyzed the samples via liquid chromatography mass spec, and that was to get the blood alcohol content. And they kind of use that to compare the two and see which one's better and kind of do the results agree with each other as they're looking at it. The other thing to kind of note is that all the data that was analyzed was blind to clinical info. So the people that were doing the analysis of the data had no idea whether they were doing male samples, female samples, what age, how they died, if they were a chronic alcohol user or not. So just kind of trying to eliminate that bias there as they were analyzing the data. So just kind of pulling the data separately. So the data that we see here was that they had 37 of the cases with an alcohol history. And so that was, remember, based on the medical or doctor records. And so 12 of those were not detectable, did not have a detectable BAC. So that's about 32%. So pretty significant number of them did not have any detectable BAC, even though they had an alcohol history. Well, 25 did, so 68%. So just based on those numbers in blue there, I would say that the blood alcohol content, the LCMS that they use to find that, is not maybe the most reliable way to test for an alcohol history or an excessive alcohol use. On the flip side, they found that cases with an alcohol history had a much higher VH-ETG level, and so that stands for vitreous humor. And then the ETG is the ethyl glucuronide. And so a much higher level we see here for those that were cases with an alcohol history than we do for cases with a low alcohol history or no alcohol history. So we had about 4.23 milligrams per liter with a standard deviation of 4.85. So pretty high standard deviation there, but still a much higher mean VH-ETG level for people with an alcohol history than that for people without, which is only 0.18. We also see a pretty high standard deviation there relative to the 0.18 mean. But again, overall, even with kind of the max level here, would be pretty low comparatively. The other thing they tested was the serum ETG levels, and they noticed a pretty similar trend. So we see a 6.9 plus or minus 8.9 milligrams per liter for people that had a history of alcohol use. And so again, we have a pretty high standard deviation here, but that 6.9 mean is much higher than the 0.4 mean for people that did not have a history of alcohol use. And again, the 0.4 had a plus or minus 0.9 milligrams per liter standard deviation, so pretty high there. The graphs you're seeing on the right here show the vitreous humor ETG levels for a couple different things. So the top one, we've got alcohol negative versus alcohol positive. So this is just kind of the points that are plotted here for the people without a history of alcohol use. And so as we see here, they had a pretty obvious, much lower VH-ETG level versus the ones with a alcohol history of use were much higher. So the highest point way up here, a pretty good concentration low, but kind of our average here, the 4.23 is much higher. On the bottom graph here, you see the VH-ETG levels compared to the blood alcohol content results. So the blood alcohol content negative, those 12 that were blood alcohol content negative, plus the ones that were blood alcohol content negative without an alcohol history, we see that they had pretty low VH-ETG levels here, but then we also have a couple, maybe outliers, but maybe just different points here that are a little bit higher. And so on the positive side, we see mostly kind of a trend of these higher ones, but nothing way up here. So overall, we're seeing these higher results kind of randomly here, and is just kind of supporting the idea that the blood alcohol content was maybe not the best way to show if there was ETG in the blood, because the VH-ETG was not quite lining up there. For these three tests that they did, the VH-ETG sensitivity and specificity were both pretty good. So we see we had a 92% sensitivity with the VH-ETG, and we had a 91% specificity. So the immunoassay had pretty high, both of these, sensitivity and specificity, which kind of speaks to how good it is of a test, because it's finding the right thing and it's actually giving the results accurately. The serum ETG we see here is pretty good, but it's a little bit lower. So it's an 84% sensitivity and an 88% specificity. So we kind of see the vitreous humor was kind of a better way to be looking at that. And then the blood alcohol content had a pretty low sensitivity, so only 68%. So not super sensitive to that, but the specificity was really good. So some advantages, some disadvantages of using the blood alcohol content and measuring via the LCMS. The other thing to note is that this is basically for correctly classifying individuals with or without a documented history of excessive alcohol use. So this was kind of comparing to those police and medical records that they already have.